Scale models. Maths is fairly easy, but the concept tricks a few people. This is a model of a train. The scale is 1 to 4. This means that every length in here is a quarter of the lengths in this one. If we look at the height, for example, if we make the height of this x, then the height of this, the real train, is 4x. Both objects are in proportion to each other. The real train has lengths that are 4 times as long. The model train has lengths that are a quarter as long. What do we look at first? And any question you find the scale, it's going to be something like 1, 2, and then a big number. Normally it's given in the question, such as 1 to 100, but sometimes you need to find the scale factor from an example. For example, it might tell you there's a 400 centimetre object is only 2 centimetres on the model. So the scale factor is 400 over 2, which equals 1 to 200. Or we might be told that 1 centimetre equals a half a metre. Well, there's 100 centimetres in a metre, so that is 1 to 50. Occasionally, you need to measure an image to determine the scale factor. Notice I'm using the terms scale factor and scale. You can use any term really. So, common questions. Easiest common question is from real life to the model. We've got a length in the real life. How long is it going to be in the model? Imagine the scale factor is 1 to 50. The real door is 2 meters high. How high is it in the model? 2 meter divided by 50 is a bit awkward. So let's translate 2 meters into 200 centimeters. Then the height in the model is 200 divided by the scale. Scale is 1 to 50. So that's 200 divided by 50 equals 4 centimeters. And of course, you know me, we can check this. Let's work out if the model height is 4 centimeters, what's the real height of the door? So 4 times 50 is 200. So we're back to the 2 meters. Perfect. So what do? We convert, first of all. Let's get into something simple, and normally centimeters does it. And then we apply the scale. In this case, dividing by the scale to go from the real life down to the model. The other common question, going from the model to real life. The scale again is 150. The model car is 7 centimeters long. How long is the real car? Well, the real car is 7 times the scale, which is equal to 350 centimeters. We can leave the answer as 350 centimeters unless the answer asks for meters. Why complicate things? And of course we can check. We ask ourselves, if the real car is 350 centimeters, how long will it be in the model? Well, if the model is equal to 350 divided by the scale, which is equal to 7 centimeters. So that got us back to where we started. So I feel good about that. What did we do? We applied the scale. In this case, multiplying the model length to get to the real length. And then we didn't bother to convert. What do I do when I see one of these questions? I have a think. What am I looking for? I'm looking to find the scale. That's the essential. That's the first thing you should look for. Then we decide, well, which way are we going? Are we going from real life to model? Have we been given the length in the real life and we need to find the length in the model? Or have we been given a model length and we want to find the real life? If it's the real life, then we're getting smaller. We're going from a humongous thing down to a small model. So we take the length and we divide by the scale. If we're going from the model to real life, from model to real life, we're going from something small to something very big, often very big. So it's length times the scale. I hope that's been helpful. What do? We think about the scale. We make the decision which way we're going and then we do the calculation. This is a tricky thing unless you know what you're doing, but once you know what you're doing, I hope you'll agree it's pretty easy. The maths is simple. The marks are low, but it comes up every other year. Why not subscribe? We're bringing up lots of videos. And if you're taking an exam soon, best of luck.